Hello, welcome to the lesson on the laws of exponents. This is Miss Silverstein, and in this lesson, we will explore the mathematics behind multiplying and dividing numbers written in exponential form. Let's get started. A number written in exponential form consists of two pieces, a base and an exponent. This is especially important because before we can apply exponential numbers, we need to identify what an exponential number looks like and its pieces. Exponential form. Here we have a number written in exponential form. The number 2 represents the base, and the number 3 represents the exponent. The exponent tells the base how many times it should multiply by itself. Therefore, since the exponent is 3, we will multiply 3 2's together. The solution is therefore 2 times 2 times 2, or 8. Let's now apply what we know about exponential forms into this example. We have 5 cubed times 5 to the 5th power. 5 cubed is written in exponential form because 5 is our base and 3 is our exponent. So looking at this box here, this represents 5 cubed. 3, the exponent, is representing how many times 5, our base, should multiply by itself. 3 times. 5 times 5 times 5. This multiplication sign comes down, and we're going to multiply 5 cubed by 5 to the 5th. Again, the exponent of 5 tells the base 5 to multiply by itself 5 times. Bringing all of these numbers together, we now have a total of 8 5's being multiplied together. We can simplify this in exponential form. We're multiplying 5's, so our base is 5. We're multiplying 5 8 times, so 8 is our exponent. What we have just done is multiply exponential forms together, which leads to our first rule. When multiplying exponential numbers with the same base, step 1, keep the base. Step 2, add the exponents together. Look at the example to the left. We have x squared times x cubed. The bases are the same, so we keep the base of x and we add together the exponents 2 and 3 and get 5. This is true based on our work on the previous slide. Let's now move on to another example in hopes of proving our next rule. Now we are dividing. We have x to the 4th, in other words, x being multiplied by itself 4 times, divided by x squared. The base x is multiplying twice. We can cancel out 2 x's, leaving us with 2 remaining x's multiplying by one another. We're multiplying the same number, or the same base, so we keep that base, and we add together the exponents. That's true based on our last proof. Let's take a look at this. Now we're dividing x to the 4th divided by x squared, and we got x to the 2nd power. We now have a rule. When dividing exponential numbers with the same base, keep the base and then subtract the exponents. Look at this example to the left. 4 cubed divided by 4 squared. the bases are the same, they both have a base of 4, and we subtract the exponents. 3 minus 2, which gives us 4 to the first, or simply 4. This is true based on our work on the previous slide. Let's now practice some examples. We now have our two rules when multiplying exponential forms with the same base and when dividing exponential forms with the same base. At this point in the lesson, you can either continue or pause and look back at what we have just discovered. Nevertheless, let's begin. Our first example is 10 to the 5th power times 10 to the 18th power. The first question you should always ask yourself is, do my exponential forms have the same base? Well, yes, they do. They both have a base of 10. And both of these numbers are indeed written in exponential form, a base and an exponent, a base and an exponent. Remember what to do when we're multiplying exponential forms with the same base. We keep the base of 10 and we add together those exponents. So we get 10 to the 23rd power. Our next example, 5 cubed divided by 5 to the 2nd power. Both of these numbers are written in exponential form. In both cases, we have a base of 5, and on the numerator, our exponent is 3. In the denominator, the exponent is 2. Let's recall what to do when we're dividing exponential forms with the same base. We keep the base of 5 and subtract the exponents. Our final answer is simply 5. Above here, this is the work behind why that rule is true. However, now that we have a rule, this is all the work that's needed. Likewise, the same can be done here. We're dividing exponential forms with the same base. In this case, the base is 10. So we keep a base of, or rather, x. We keep that base of x and subtract our exponents. 20 minus 16 is 4. And this is only true when the bases are the same. The rules of exponents. Remember, when the bases are the same, we keep the base and add the exponents when multiplying, and we subtract the exponents when dividing. In general, this is only true when the bases are the same. Thank you for watching this lesson on the rules of exponents with Ms. Silverstein. You can always come back and re-watch the lesson again and pause it as necessary. This lesson was created using Powtoon. You can come to Powtoon and create your own lesson as well, using all of the features. There's text effects, image holders, props. You can add your own sounds and eventually save your work. This is Ms. Silverstein, and until next time, have a great day.